Nowadays, climate change is one of the biggest issues. Every day, new solutions are found in all fields. However, the aerospace field is lagging behind.
It's why we decided to demonstrate that solutions exist and that we can exploit them. For our secondary mission, we decided to drop seeds.
Our Cansat has been specially designed in the spirit of our secondary mission. First of all, it is equipped with a drop system capable of releasing up to 300 grams of load. Secondly, it is assembled using threaded rods, which will allow us to disassemble and reassemble it as many times as necessary. Then, it is completely modular. It is made up of several layers, which can be arranged in several different orders. This Cansat can therefore be suitable for other types of missions and therefore avoid producing too much carbon dioxide. Finally, our Cansat also allows us an easy access to the battery in case of problems. We have developed with the help of Python data processing software, which allows us to plot live graphs, automatically save the data, and plot a graph of the trajectory in the space of our Cansat. When we will launch the program on a launch day, graphs will be formed: temperature, pressure, altitude, speed and humidity. And the curves will be drawn live. The data will also be displayed in a frame. There is also a button that will allow us to operate the drop system remotely, depending on the altitude that we can read just below. Here you can see a test we did in January.
We did this test with our antenna at a distance of more than 200 meters.
Then, all the graphics will be saved so that we can efficiently prepare our preparation. All the data will also be saved to an Excel file so that we can reuse it as much as we want. And finally, a graph of the trajectory will then be created. This example is in fact me walking in my garden.
Hello, I'm Romain, and together with Cassandra and Adrien we are in charge of the secondary mission. It consists of trying to achieve a zero carbon emission mission. To do that, we are planning on planting seeds that will absorb the CO2 we emit during the project. My job was to calculate how much CO2 the mission emits, and one method to calculate the amount of CO2 our seeds will absorb. Unfortunately, due to recent COVID measures, we haven't done my method yet, but we have all the calculation necessary to show you how our zero emission mission works. Let's talk about the CO2 we emit. As you can see on the screen, there are two tubes. The left one is the amount of CO2 the mission emits, and the right one is the amount of CO2 our seeds will absorb as time passes. We have four big categories of CO2 emission. The first is the Cansat itself with 49 kg. Then comes the 3D printer with 151 kg. Then the journey with 145 kg. And finally, the flight of the Cansat with only 0.012 kg. In total, we emit 346 kg of CO2. To compensate for that amount, we have our seeds. Cassandra will explain it to you.
Hello, I'm Cassandra and I'm in charge of the seeds. We have found that the seeds absorb 0.382 kilograms of CO2 per square meter per year, and with our 30 grams of seeds, we have 1.5 square meter of plants. With that in mind, we'll need 604 years to compensate for our emissions. Now, let's hear what Adrien can say about our experiment.
Hi, I'm Adrien, and my task was to make sure our calculations would match reality. For the first experiment, we needed a bit of soil and a few milliliters of chlorhydric acid and sodium hydroxide. Once we had them all, it went as follows. We connected the bottle filled with soil with another containing sodium hydroxide and let them react. After that, we titrated the remaining NaOH with the HCl. By knowing the volume of titrant, we could calculate the amount of sodium hydroxide that had reacted with the soil, and thus how much CO2 our little plants have absorbed over the course of 6 weeks.
To conclude, we are firm believers in ecology, and we hope that one day it will be possible to work in aerospace in an ecological way. Our mission isn't a complete success because 604 years still ahead. However, we hope future teams will be inspired by our love for science and ecology, and we encourage them to think about other solutions.